computer. We're recording. Great. Share screen. Close that bad boy down. Let's look at 1.8. Okay. So projectile motion. So this is when you're launching something in the air at an angle. We like to know what's happening. So first off, objects in flight. And actually, let me expand that too. Objects in, come on, man. Only under the influence of gravity. So that's what we're dealing with, a projectile. So you're launching something and gravity is going to bring it down. That's really, in other words, you're launching and gravity brings it down. That's in essence what projectile motion is. The X and Y components are independent. They don't impact each other. So what this means, you have to do two analyses. A vertical and a horizontal. We must do two analyses. Time is the only quantity that'll be the same for both. So you can think as time as a bridge. So whatever time you get when you do your vertical analysis, you'll use that time for the horizontal analysis. So very important. Let me write this out actually. Whatever time value, I'll take a little break so you guys can copy this. You solve for when doing vertical analysis, use it for the horizontal analysis. That's what was meant by time as a bridge. The time helps you bridge those two analyses. The X component velocity. So whenever you solve, so that's going to be Vx is going to be constant. Since nothing is pulling it sideways. So we kind of just say, we might be using that formula to find horizontal distance, where x is going to be your horizontal distance. Because remember, the acceleration is only vertical. So y component changes. Let me change colors up here. Because gravity is pulling it down. So we use kinematic equations. That's why you're going to do the vertical analysis first and the horizontal analysis second. You got to do the messy stuff first to solve for, usually you're going to be solving for time, and then use that in the horizontal analysis. If the starting and ending heights are the same, so you throw something up and you want to catch it, right? You don't move your hand. Then the distance object can be found with the range equation. Actually, that's a little bit confusing. I'm not sure what they mean by that, actually. We'll just come back to that in a little bit. I'm not sure what's meant by that last bullet point. But yeah, so now let's actually go through some examples. Yeah, we got several examples here that we can do as part of our lesson. Any questions so far before we move forward? Okay, let me just explain the diagram to you, by the way. The diagram looks a little messy here. So let me clear. So this is right at launch. You have your velocity. And you have your velocity in the x direction, your velocity in the y direction. Now let's take a look at the peak. What happened to Vy at the peak?
Said 0.
Why?
Well, because now it's no longer going up, but it's not going down. It's kind of
Yeah,
like,
momentarily it's not experiencing any vertical motion. For a brief moment, there's no vertical motion. Remember, what are we studying here? We're studying motion. Kinematics is purely about motion. And when it's at its peak, it's kind of just stalled for not even a second, even less than a second, but it is stalled for a little bit. So there's no velocity in the y direction. Now, notice Vx is the same the whole time. These little blue arrows, it's a constant because there's nothing pulling it sideways. Remember, it's only acceleration due to gravity that's impacting us here. And the acceleration due to gravity is vertical. So so it just stays the same all the way through. So that's just kind of dissecting that diagram that you see there.
Mr. Master, is it's like at theta 0 right at launch, and when it says theta 0, or at, I guess that's what it said.
Yes, the initial angle.
That initial angle almost like flips when it comes down on the other side.
It will. Yeah, it should.
Oh,
yeah, because as long as it's coming back to the same height. I think that's what's meant by that last bullet point, actually. But we're not going to be using that in any way mathematically, so that just seems kind of weird to me. But the angle, of course, will change because your vertical leg, Vy, the vertical leg of the right triangle, is getting smaller, so it's changing the angle. But we don't worry about that in our calculations. We just, as long as we know the initial angle, everything all takes care of itself using the right equations. So let's do this problem here. Okay, a veggie meatball with that velocity rolls off a 1 meter high table. How long does it take to hit the floor if no one sneezes? Okay, it's weird. Okay, and what's the velocity when it hits the floor? Okay, so first off, this is not projectile motion, by the way. This is just you simply have a table. Even if it's a veggie meatball, it's still gonna look brown, as you do. And it just falls on the table, falls off. So There's no angle or anything I have to really worry about. We're not launching it. But yeah, we do know that it's a 1 meter high table. So I'm going to say my y0 is 1. My y is 0. And remember our equation. Remember, A is negative 9.8. We'll just do negative 9.8. The 9.81 thing is just not necessary. Initial velocity is 0 because we didn't it just fell. We didn't push it off. We don't care about final velocity, at least not yet, because we're in the first part of this problem. And time is what I want. So that's why we're using this formula here. So y minus y0, bring that to that side. 1/2 of 9.8 t squared plus 0. That's of course negative. Sorry, it's negative.
Well, why is the initial velocity 0?
Because well, what it's the assumption, and I'll have to state this on our test so it's clear. The assumption is that it's just rolling off. It just kind of just sort of it was just hanging there, and maybe I don't know, it was just about to fall off and it just did.
But I thought it was rolling off with that speed of 5 meters per second.
Oh, you're right. I didn't read that carefully. Then it is still free fall, mind you.
Yeah.
Yes, you're 100% correct. Thank you for catching that. So, and it's actually pointing down, by the way, because it's going in the down direction. So you're going to have to say -5. V, I don't care. T, I want. Thank you for catching that. Yes, now y minus y0 equals 1/2 negative 9.8 t squared is connected to it minus 5t, and of course y minus y0 is -1. That's negative 4.9. Moving over to one side and just quad form it. And I'm just going to kind of just give you the answer. I think the answer is oh, wait one sec. Hold on. No, I was right. No, I was correct. Let me okay, I could see. Okay, so well, this is a good discussion point to have. I'm dealing with vertical motion. If it's rolling off at 5 meters,
Oh, wait, that's the horizontal motion. So then the vertical
it's horizontal motion. Yeah, I would be. Yeah, you can see why it's hard to write these problems. That should have been more clear. It's not like you're throwing it down at 5. You're flicking it, right? So it's on the table and you just flick it with purely horizontal. So it's actually purely horizontal. So I'm not going to use that. So I'll still write and say, but I wasn't clear as why I was right. But great discussion point to have. Okay, take 3. Sorry about that. 1/2, again, negative 9.8 t squared plus 0, and that's -1 equals -4.9 t squared. So when we solve for t, I'll just kind of tell you right now, it's going to be about 0.45 seconds. Now, we can use the time as a bridge to tackle some other parts of this problem. So first off, I do know that, so what is its velocity when it hits the floor? So in this case, I want to solve for Vy. So now I could use this formula. So I want the final velocity, but in the y direction. Initially, the velocity in the y direction is 0. The acceleration I know is negative 9.8. And I could use time now. And I don't care for distance. I don't care for that. So the formula I'm going to use is this. Acceleration equals v minus v0 over t. But because I'm doing this in terms of y, so negative 9.8 equals vy minus 0 over 0.45. And if you solve for vy, you should actually get negative 4.4. So I'm still using my kinematic equations. I have to use what's given. So yes, I was given the distance, 1 meter, but we made it -1. I know the initial velocity in the y direction is 0. I know the acceleration. I solve for time. Then actually, I use that time to help me get the rest of the problem. It was still free fall, mind you. That was still what's happening there. But here's a slight little thing I'd like to add to this. Because of this, let me erase this here. So we flick the meatball. So actually, it's going to land somewhere a little far away. How do I find where it lands? That's going to be the range equation, or and I already know what Vx is 5. I know the time's 0.45. And so if I were to actually solve where it lands, whatever that is, what is that going to be? .25. So you would expect that to happen, right? If you took a ball and you kind of flicked it, it's going to fall a little bit in front of the table, right? So that's what's happening there. So let's actually look at in the interest of time, let's skip the problem in the middle. Actually, yeah, let's go to the one about the batter, because I think that's important. And then we'll have a little discussion on some stuff in the middle, and then we'll do some problems in groups today. Okay, so let me clear my drawings. Okay, so let's go right here. There's some stuff on the other page of how far did the ball go. Okay. Okay, a batter hits a ball at 35 degrees with a velocity of 32 meters per second. How high did the ball go? So what I want to do first, it's still the same stuff that we've always been doing with kinematics, but you want to actually, so this is your initial velocity. So I want to find initial velocity in the x direction, initial velocity in the y direction. So the initial velocity in the x direction is going to be 32 times cosine of 35 degrees. In the y direction, remember, we're always using sine, so 32 times sine. So I'm kind of cutting some corners here because I'm not, I could say cosine 35 is v0 y over v0. Sine 30, sorry, that's sine 30. Cosine 35 is v0 x over v0. That just takes a while. I think we can just kind of just go straight to it. Make sure in degree mode in your calculator, if you do this in a graphing calculator, come on, man. And again, you can always use Desmos if you don't have a graphing calculator. That's totally fine. I mean, even your cell phones can do this too. So, all right. So how high did the ball go? So because I'm doing vertical motion, you're going to want to use this first. And also you're going to want to use the solve for time as well. But how high did it go? Okay, so I know my V0 in the y direction, 18.35. I know my acceleration due to gravity is negative 9.8. I want to solve for y minus y0. I don't know that. And I know my velocity in the y direction is going to be 0 at the peak. So the equation I'm going to use is this right here. And just so I'm consistent, I probably should put these little y's here. So I'm solving for y minus y0. So I just need to grab my charger because I realize my computer's about to die. So why don't you guys go ahead and solve for this. So you're solving and you have all these numbers here you can now plug in into the equation. So go and do that. I'm going to grab my charger in just a sec. Okay, I'm back. I'm actually gonna just plug this in my calculator. So let's see here. So I should have 2 times 9.8 on one side. Come on, 2 times 9.8. And I gotta do 18.35 squared divided by 19.6. Did anyone get this as their answer? Yes, no? Okay, good. I'm seeing some nods of approval.
Yeah.
Great, awesome. All you need to do, just so you know, in case you didn't get it, remember you're playing a 0 squared equals 18.35 squared plus 2 times negative 9.8. It's got to be negative because that's going down, times y minus y0. And you're not separating y or y0. You're just solving for that chunk there. And you just got to move stuff to the other side and you should be fine. So that would be, yeah, my answer key has that. Yes, perfect. Okay. So next up, we now have to solve for how long the ball is in the air. So we got to solve for the time. So you could actually just use, so I'm going to clear this right now. So we could use this formula next. Or remember, y minus y0 and I already forgot what v0y was. Hold on. That was 18.4. Yeah. And y minus y0 is 17.17. Moving over to one side. And work it all out. And yeah, if I could just graph that on my calculator or use quad form. In interest of time, oh wait. Okay. I made a little mistake here. What's the question asking? Was the question how long it took the ball to get to the peak, or how long the ball was in the air total?
How long was the ball in the air?
Yeah. So this time, actually, if you solve this, there's nothing wrong with that. Actually, you know what? I'm just going to do that because I'm just curious to see what I get. So you actually don't erase what you just wrote. I mean, you're still fine. But remember, I'm actually solving for the time it takes to get to its peak. So 4.9, 18.4, negative 17.17. Okay, so I got point. Yeah, so I want to get a 0.776. I guess that's how long it took to get to its peak. But what I really, really wanted, and actually let me look at my coefficients again. Oh, that should be negative, by the way. So let me do that one more time. Actually, I think I did it a little incorrectly. Yeah, no, I got it now. So I get 2, well, it's not quite accurate because it should be actually just one time value, but that's okay. So it takes about if you do it correctly, it should be about 1.9 seconds. And you actually should just get one answer. if you actually have the accurate numbers. Now here's the thing: if you launch something like this, if it takes 1.9 seconds to get here, how long do you think it will take to get over there? Just use some intuition here.
3.8.
3.8, yeah. You could totally double it as long as the heights are the same on both beginning and end. So what I should have done, personally, to answer this question correctly, it's an easy fix. It doesn't require much change, but I should have put a 0 here and then factor out t. You can see why you have to be really, really careful with stuff. So t equals 0 or 3.8. But I wasn't wrong in my analysis. I could have kept it at 17.1 whatever. But I would have to make sure that I'm using accurate numbers. Like I'd have to make sure my velocity in the y direction wasn't rounded too much, because I obviously rounded it a little bit too much. Y equals the y minus y0. So I have to use very precise numbers. If I did, then I would get t as about 1.9 and double it. And we're assuming that the height that the ball leaves the batter is probably going to be roughly the same height where it's caught. You know, you see most batter, you probably hit the ball maybe about 4 or 5 feet off the ground. It's probably caught at around the same height. So we kind of make that assumption. How far the ball go? That's an easy one. That's going to be your range. That's the velocity in the x direction times time. Velocity in the x direction, I already forgot what that was. I think it was, yeah, it should be 26.2. If you did 32 times cosine 35, yeah, it's 26.2, 1 times 3.8. And that'll get you how far. So it goes about 99.6 meters. Yeah, that's kind of roughly what we expect. And if you actually were to actually multiply that by about 3.2 or 3, if you were to convert that to feet, that goes about 318 feet. If you play baseball, that's kind of like the distance from the batter to like center field. I mean, home runs usually about 350, 360 feet, maybe longer, depending on where you're hitting the ball. So you always want to make sure your numbers kind of make sense too. In the game of baseball, that kind of makes sense. I mean, of course, again, we don't use meters, we use feet. But if you were watching a baseball game and say, when they used to have a baseball team in Montreal, Toronto, they do, you know, when they play games in Mexico or Japan or now Korean baseball is all the rage because it's one of the few sports out there. They tend to use, they should be using meters, but I think Toronto probably uses feet just to keep it consistent with all the American countries. But I think if people had their way, they would want to use meters because we're just so special. We have our own system in our country. Okay, so we have a little bit of time left. So any questions so far? Nope. Okay, so now you guys are going to practice. We'll practice for maybe about 15 minutes or so. I'm going to find a problem that seems reasonable. Maybe we'll have you guys do a couple. Let me think here. I want to do something that's kind of consistent with what we've already done, so it's not too challenging for you guys.
Mr. E, I have a question.
Yeah, go ahead.
For like the problem sets, do you want us to finish all the problems?
No, I'm gonna actually. What I'll do is when I post the homework tonight, I'll post the homework. Homework tonight's just gonna be tonight. Your main concern should be do the review set and finish up the discussion.
Okay.
I'll put a separate thing, a separate assignment in Schoology called problem sets. I'm gonna make it due Sunday, not tomorrow, and I'll put specific problems I want you guys to do. And what you really need to do is you just need to show me like one problem from each of those things. I mean, if you want to show me more, that's fine. just want to make sure you're doing it. That's all.
Okay.
Yeah. So I'll put more clarity with that by tomorrow, but it won't be due tomorrow. We'll make it due Sunday. Hold on, let me just try to find a good one here. Something that's got an angle involved. Maybe 9's a good one. Yes, let's do 9. We'll just do number 9. That's like enough for now. So let me put you guys in breakout rooms. So again, we're doing number 9 of 1/8. Okay. We'll do 4 rooms. Random. We'll make this 15 minutes, 1 minute. So, and I'll hop in each room in the next minute or two. All right, you guys can go now. So again, you're number 9. Hey, excuse me. Excuse me. How's it going? Any questions so far, or you guys are okay? Okay. Well, I'm going to work it on the main room, and then we'll go over it when you guys get back. How are you guys doing so far?
I was like one. I was one off on the, and I don't know why.
What do you got?
I got 25.98 for. I got 25.52 for A. I don't know what I did wrong.
You get 25.98.
I'm sorry, I got 25.52, but I started with 25.98 with the vertical.
When you're using when you're using 60 degrees, you may have rounded too soon, perhaps. That could be it. Like,
Should I have used 26?
Hold on one sec. What was that?
Should I have used 26 for
26. Let me get my calculator out.
Yeah, I'm still off. Because it should be x minus x0 equals 1/2 times negative 9.8
So
times 4.0 squared.
yeah,
plus
25.98 is your vertical velocity.
Yeah.
You already know the time. You want to get the height of the cliff. So you want to use that y equals 1/2 at squared b0t plus y equation.
Yeah, I did all of that, but I don't know. I just, that's why I'm confused, because I'm pretty sure I did everything right, but I'm still off.
Let me just keep going with the problem. That's okay, because at least you're doing the process. That's what I really care about. Maybe they're wrong. I don't know. I have to work up. But
No, I'm definitely wrong, but it just pissed me off. I don't know why.
I'm sorry. Hold on, let me make sure I'm reading this carefully. Let me think about this again.
Oh, never mind. I know why. It's because it started 1.5 meters off the ground, so you have to add 1.5 at the end.
Oh, there we go. Okay. Okay. That makes sense then.
Yeah, that gets me.
You're okay. You're fine. Okay. Cool.
Oh, okay.
All right. You feel better?
Yeah, I can
Good.
sleep now.
Okay. Nolan, you had a question.
My question was, should we use 30 meters per second, or should we use VY initial?
You have to convert it. You have to find the vertical velocity. So you have to do 30 times cosine of 60 degrees.
Yeah, we kind of figured that out.
Mm-hmm.
So thank you.
Yeah, then you have 25.98, and you kind of use that.
Yeah.
For the first part of the problem. Okay, cool. And I'm going to work this out in the main room and share with everyone before we break for lunch.
Yeah.
Hey guys, do you have any questions?
Yeah, I had just one.
Mhm.
So when because it says that the height is at 1.5.
Right.
But that's not the same as the y minus y0.
Yeah, y
right?
minus y0, you solve that separately.
Uh-huh.
And then bring 1.5 back in. And then you should be able to solve for the actual height of the cliff.
Okay.
Did you get 25.5 as your answer for the y minus y0.
Yeah.
Yeah, add on 1.5, you get 27.
Do that. Okay.
Yeah, that's just a minor thing.
And you use, because it's giving you 4 seconds, because it says that it then you use that for the time.
Right, so that you're using the equation y equals 1/2 at squared plus v0t plus, yeah.
Okay.
So you plug in 4 for t, you know your a is negative 9.8. You know your initial velocity is going to be 25.98 when you do the 30 times sine of 60 degrees. Right, good, you guys are good. Yeah, I'm going to work out in the main room, and then in a few minutes I'll bring you guys back and we'll just check our work.
Okay, sounds good. Thank
Cool.
you.
Hey, Brandon, just wrapping this up here.
Mr. Almashni,
Go ahead.
what so I used for acceleration on part A I used 0.81, and I actually got like, I mean it's a slight difference, but it's still like a little bit different.
It's okay.
Yeah.
Not a big deal.
That's like which one
Yeah.
to use.
1 sec here. 25.98. Shoot, look at that. Hmm. 25.98. Oh, it's negative. Crap. I get 25.98 squared minus 2 times 9.8 times 27.02. Hold on. $25.52. Great.
You can request as much as you want. I feel
Yeah, I know. It's lit. I was
Hey guys, what's up?
Button mashing it. We are so confused as to which equation to use for part C.
I am too. So we're gonna go back to the main room.
Like, I don't know which one is irrelevant or not. 'Cause I know
Yeah, we'll come back. Let me close the breakout room. We'll go over the other two parts first.
Sweet.
Oh darn! All my work got erased. That's frustrating. Okay. Okay, we'll wait for everyone to get back. I did all that work for nothing. Okay. Looks like most of the guys are back. So we're gonna break for lunch. So I actually had worked out parts A and B, and I should have actually taken a snapshot of it. I did get the answers for A and B. C, I'm a little confused about, so I need to actually work that out again, because for some reason I didn't quite get that correct. But were there any questions about A or B that you guys wanted to go over? Did you guys get them? The answers?
I got a big answer for B. It's not the same as.
Okay. So let me quickly go over it. So I'll share my whiteboard here. So for 9B, you're trying to find the maximum height. So you want to know when it hits its peak. So you're going to use this equation here. V squared equals, so it's Vy by the way. And momentarily when you're at the peak, the velocity in the y direction is 0. And you should have got 25.98 if you did that correctly with the trig for the initial velocity. That's 30 times the sine of 60 degrees, you know? So plus 2 times negative 9.8. Not sure, hopefully you did negative 9.8. If you work all that correctly, you should get 19.6 times y minus y0 on this side, and 25.98 squared, excuse me, you get 674.96. Divided by 19.6, you get 34.44. And because your initial height is 1.5,
I see.
add over, you should get 35.94, which is close enough to 36 meters. And I'm actually going to take a snapshot of that right now because I don't want to lose that. So that's part B. Part C, I tried working. I didn't quite get the answer. We'll talk about it after the break. I don't know what I'm doing wrong there. Hold on. Let me just move this around. Come on. .8 over 9. So our section. Okay, at least got that saved. So okay, so we'll break for lunch right now. Let's come back at 12:15. So you guys get about 30 minutes, and yeah, then we'll come back. So you guys can just stay on or sign up to come back later.